In this session, let us see about primary memory and the types of primary memory. In the earlier session, we saw about memory. So, what is the purpose of memory? It is to store data before as well as after processing. We require physical devices to do so that it can store the programs as well as the data. If the data is stored in the chips, we call it as memory device. If it is stored in the tapes or disks, we call it as storage. The data which is stored can be temporary or permanent. Having seen this, let us look into what is primary memory. What are the characteristics of primary memory? Primary memory is also called as main memory or internal memory. Why it is called as main memory? Because it can be accessed directly by the CPU. These primary memories are semiconductor memories and they are volatile in nature. What is meant by volatile? It means when the power is switched off, the data is lost. This kind of primary memory is used to store programs as well as data temporarily. In the sense, we can also call it as the working memory of the computer because the computer stores all its execution onto this primary memory. Most often, we refer this to RAM. We include cache also. These primary memories are faster than secondary memories. A computer cannot run without the primary memory. So these characteristics make up the nature of primary memory. Let us now look into the characteristics which are for the secondary memory. These secondary memories are also called as external memory or auxiliary memory. The storage capacity of primary memory is not enough to store large amount of data. Hence, we depend on the secondary memory. If data is present in the secondary memory, it cannot be directly accessed by the CPU. So, first what has to be done is, it has to be brought into the main memory and then it has to be brought into the CPU. Secondary memories are magnetic and optical type of memories. They are non-volatile in nature. As you have already seen, volatile means when the power goes off, the data is lost. But when we say non-volatile, it means the power is retained even if, when the power goes off, the data is retained. What I meant is, the data is stored permanently even after the power is switched off. So what do we use this memory for? We use this secondary memory to store infrequently used programs permanently. Hence, this secondary memory is also called as backup memory. These kind of secondary memories are capable of storing large amount of data. Example, hard drives, floppy disks, magnetic tapes, USB flash drives, CDs as well as DVDs. These secondary memories are slower than primary memories. Can the computer run without secondary memory? Yes, of course. The computer can run without secondary memory, but it is very much required that we need to have primary memory for the computers to run. Having seen the characteristics of primary and secondary memory, let us move on to the types of memory. So, on the whole, memory can be classified into primary memory as well as secondary memory. Again, we can classify primary memory into ROM and RAM. ROM can be classified into PROM, EPROM and EEPROM. So what is PROM? It is programmable read-only memory. EPROM is erasable programmable read-only memory, whereas EEPROM is electrically erasable programmable read-only memory. We have two types of RAM, namely the static RAM and the dynamic RAM. The secondary memory is further classified into floppy disk, hard disk, optical disk and magnetic tape. The optical disks are classified further into CDs and DVDs. These are the different types of memory based upon whether the storage is temporary or permanent. Let us now see the differences between RAM and ROM. RAM is volatile in nature, whereas ROM is non-volatile. Instructions are written during the time of execution into the RAM, whereas we write instructions onto the ROM during manufacturing time. Sometimes we even erase the information and write information onto ROM. The storage RAM is used for temporary storage, whereas ROM is used for permanent storage. RAM is used for normal operations after loading OS, whereas ROM is used during the startup process. We use RAM in the CPU cache, or we use it as a primary memory, whereas ROM is used in the firmware as well as the microcontrollers. We can read and write into a RAM, but into ROM we can read. The storage and chip size. RAM is larger than ROM. In the sense, RAM is of the order of gigabytes of storage, whereas ROM is megabytes of storage. The writing speed is faster in RAM, whereas ROM is slower. RAM is faster in assisting the processor, whereas ROM is slower and it cannot boost up the processor speed. Even though RAM and ROM, they work very fast, the power consumption is more in the case of RAM, but ROM consumes only very little power. So having seen the differences between RAM and ROM, let us see the characteristics of RAM. All of us would have seen the RAM which is used in the system. RAM is an IC chip which consists of one or more modules. It stores data randomly and temporarily while the computer is running. It is volatile in nature and the types differ in the techniques used to hold the data. RAM can be accessed much faster than the storage devices. If you take into consideration the data transferred between CPU and the RAM, it is 100 times faster than between the CPU and the hard drive. There are two types of RAM, SRAM and DRAM. Having seen the characteristics of RAM, let us go for the first type, which is SRAM. SRAM means it is static RAM. Each cell in an SRAM is a flip-flop. It need not be refreshed like a DRAM. SRAM is faster than DRAM and it is used in specialized applications. The direction of current depicts the value of zeros or ones stored in those flip-flops. SRAMs are more reliable and it is used in level 2 cache. These SRAMs are more expensive and it consumes more power. These are the nature of SRAM. Let us see about DRAM. DRAM. Each memory cell in a DRAM consists of a transistor and a capacitor. Hence, electric charges leak gradually from the logic 1 state to logic 0 state. As the electric charges leak gradually, it changes from logic 1 state to logic 0 state. So, it needs to be refreshed every few milliseconds, which takes several CPU cycles to do this refreshing. As each cell is smaller in size, one DRAM can have larger number of cells. That means high density is possible with DRAM. It can be either charged or discharged, which can be used to represent logic 1 and logic 0. These kind of DRAM are used in primary memories. It is inexpensive in the sense it is 30 times lower than SRAM. These are the characteristics of DRAM. What are the different types of SRAM and DRAM available? SRAM is divided into asynchronous SRAMs, synchronous SRAMs, special SRAMs, and non-volatile SRAM, which is NVRAM, and battery back SRAM, which is BBRAM. We have also got different types of DRAM, such as EDO RAM, which is extended data out RAM, EDO RAM, which is extended data out DRAM, SDRAM, which is synchronous DRAM, RDRAM, which is RAM bus RAM, and DDR DRAM, which is double data rate DRAM. Let us see few examples of these types of SRAM and DRAM. SDRAM is synchronous DRAM. It is a hybrid of SRAM and DRAM. It runs in synchronization with the system bus. It is driven by a single synchronous clock. That's why it's called a synchronous DRAM, and it is used in large caches and main memories. Next is the DDR SDRAM, which is double data rate SDRAM. It is an upgradation which has been done to the standard SDRAM, wherein we have got double pumping of data. What do you mean by double pumping? It means two transfers occur per clock cycle, one at the rising edge and other at the falling edge, without doubling the actual clock rate. In a normal SDR, there would be only one transfer per clock cycle during the rising edge. But in the case of DDR SDRAM, there are two transfers which happens per clock cycle. It is one at the rising edge and the other one at the falling edge. Hence, we call this as double data rate SDRAM. These kind of DDR SDRAM, they consume low power. They are also called as SDRAM2 and DDRAM. Having seen this, let us move on to the next type, which is dual channel DDR. Two DDR DIMM, which is dual inline memory modules, they are installed at one time. They function as a single bank, doubling the bandwidth of a single module. There are two types, which is DDR2 SDRAM, which is the faster version of DDR SDRAM, which doubles the data rate of DDR, it consumes low power than DDR and achieves high throughput by using differential pairs of signal wires. The other type is DDR3 SDRAM, which is an improved version of DDR2 SDRAM, wherein we have the same number of pins as in DDR2, but it is not compatible with DDR2. It means if this DDR2 RAM fails, we cannot replace it with DDR3. DDR3 SDRAM can transfer twice the data rate of DDR2. The chip sizes are available from 512 MB to 8 GBs. The maximum module size is 16 GB. What are the other types of RAM? It is NVRAM, which is non-volatile RAM. It is the only RAM that can retain data even after electricity is cut off. So already we had seen that RAM means it is volatile in nature, but this NVRAM is non-volatile. So the volatile RAM is equipped with external power supply. It takes power from the system battery when the computer is turned off. We use floating gate transistors here. Examples are flash memory. We also have this FPM RAM, which is fast page mode RAM. It is slightly faster than the conventional RAM. It sends row address only once for many accesses to memory in locations near each other. It has got improved access time. EDO RAM is EDO DRAM, which is extended data out DRAM. It improves the time to read from memory on faster processors. It has been optimized for 66 MHz Pentium processor. Having seen these types of RAM, let us now move on to the characteristics of ROM. The processor can only read data from ROM, or in the other sense, we say this RAM can only be read by the processor. New data cannot be written into the ROM. So, the data is written during the manufacturing phase itself. It contains data which does not need to be altered, such as the booting sequence of a computer or the algorithmic tables for mathematical applications. This ROM is slower and hence cheaper than RAM. It is non-volatile in nature and it is not economical to produce ROM in small quantities. It cannot be altered as RAM, but technologies are available to program these types of ROMs. So what are the types of ROM? First one is the masked ROM. It is a static ROM. It is called as masked ROM because it is programmed by the IC manufacturer. That means the user cannot program it. It can be programmed only by the manufacturer. That is why we call it as masked ROM. It has been masked for the user to program it. User cannot erase the content or he is allowed to write any contents onto this masked ROM. Since the manufacturer, he himself programs it, we call it as manufacturer programmed ROM. Actually, MROM stands for masked ROM or PROM, which is programmable ROM. But as the manufacturer has programmed it, the first of the ROM is masked ROM. It is a static ROM which is programmed by the IC manufacturer. It cannot be programmed by the user. The user cannot erase the content or he is not allowed to write new contents onto the memory. It is also called as manufacturer programmed ROM. The next type is programmable ROM. Data can be written only once, but here in this case the user can write it once. It is not done by the manufacturer. So it is manufactured as a blank memory. So the unprogrammed ROM contains data wherein the data is entirely of ones. So we can write data onto this programmable ROM by a programmer or a PROM burner. It is as the name says, it can be programmable, but it can be done only once. The contents can never be erased or changed afterwards. So if we want to change any data, it means the device must be discarded. These devices are called as one-time programmable or OTP devices. These kind of PROMs are used in video game consoles or in electronic dictionaries. The next type of ROM is erasable programmable read-only memories. They are programmed as PROM, but it allows the programmers to erase and program repeatedly. How do you erase information which is present in the ROM? It means you need to expose the device to a strong source of ultraviolet rays. So all the EPROMs will have a quartz window in the center. So we have to expose these quartz windows to ultraviolet rays so that the information on those EPROMs can be erased, and we can rewrite data onto it. So the quartz window which is there on the top of the device allows light to reach the silicon, using which we erase the information. It is more expensive than PROMs. It is used for storing BIOS information. Next type is electrically erasable programmable read-only memories. What does it mean? It means we can erase it and program it electrically within 4 to 10 milliseconds. Any byte can be erased and rewritten. That means byte level we can go and work with it. We can go and work with it at byte levels. It is similar to EPROMs, but the erase operation is electrically done rather than using ultraviolet rays. Once the data is written, a new data will remain in the device forever or for at least until it is electrically erased to load some other content. It has got improved functionality and higher cost. Handling of electrical signals is easier and safer than ultraviolet rays. So these are the characteristics of EPROM. The other type of memory which is used is flash memory. This is a special type of EEPROM wherein we can erase and program it while in circuit itself. It is volatile in nature. We can write any number of times in blocks. It is used in BIOS, USB memory stick and memory cards. Let us see the difference between SRAM and DRAM. SRAM uses more transistors and latches and data is stored in flip-flops, whereas DRAM uses less transistor in the sense it uses one transistor and capacitors, and data is stored in capacitors. No periodic refreshing is needed to maintain the data, whereas periodic refreshing is required in case of DRAM. Static RAMs are complex and are expensive, whereas dynamic RAMs are simple and less expensive. Static RAM has lower access time and they are faster, whereas dynamic RAMs, they have higher access time and hence they are slower. Storage is less with respect to static RAM, whereas DRAM can be used for large amount of storage. SRAMs are used in cache memory, whereas DRAMs are used in main memories. The packaging density is low in SRAM, whereas the packaging density is high in SRAM. What do I mean by that? It means more amount of devices, more amount of cells. It means more amount of cells can be packaged in a DRAM. SRAMs consume more power, it generates more amount of heat. It means the power consumption is more and the dissipation is also more because it requires constant power. Whereas DRAMs, they require low power because information is stored in capacitors and it generates less heat. These are the differences between SRAM and DRAM. Now let us move on to memory packaging. It means how memory are manufactured or packaged into ICs. In the earlier systems, memories were present in the motherboard. Now it is in the form of modules. There are different types of packaging. We call it as dual inline package, which is DIP. The next is SIMM, which is single inline memory module. We also have SIPP, which is single inline pin package. DIMM is dual inline memory module, and RIMM is RAM bus DRAM. SODIMM is small outline DIMM. We also have micro DIMM. These are the different types of memory packaging. How are memory packaged using DIP technology? We have small plastic ceramic packages. It has pins on two sides. This is how a DIP looks like. We also have SIPP, which is a small PCB holding the memory chips. There are 30 pins on one side with matching holes in the motherboard. This is how your SIPP looks. We also have SIM, which is single inline memory module, which is a small circuit board holding memory chips from 8 or 9. DIMM is dual inline memory module. This is also a small circuit board holding the memory chips. Packaging is used in SDRAM and DDR. Next is RIM. It is a high performance memory system wherein RIM is used when high bandwidth and low latency is required. It is found in Pentium 4 motherboards. SODIMM is used in notebook computers which has small memory form factor. It is of 32-bit and it has got 72 pins. Sometimes it is 64-bit with 144 pins or 200 pins. We also have micro DIMM, which is extremely small RAM, form factor. It is ultra light and it is used in portable sub-notebook computers. It has got 144 to 172 pins. It is similar to DIMM. So this is the micro DIMM. So far we had seen about primary memory, the types of it, and we have also seen the memory packaging. Now let us move on to the secondary memory.